Math 20-3, we're going to look at volume and capacity of prisms and cylinders. So take the new handout that you were given, and we're going to look at the first page. The first page matches to the math on the job in your textbook on page 138. So if you want to take a moment to press pause and then read that math on the job, then we can look at this question. So the question asks, which of the following boxes would be most appropriate if you needed to ship 125 boxes with a side length of 10 centimeters? Justify your reasoning. So take a moment to look at these three diagrams, pictures, and try to see what the answer or what you think would be the best one. Press pause again. Okay, so let's take a look at these three boxes. If I look at this box is a 10 by 10. And the box that I'm shipping is a 10 by 10 by 10. So that makes it a cube. It would kind of look like this. So if I put this box here like that in that tube or in that stretcher, I don't even know what to call this long box. If I put it into this long box, it's 10 by 10 and it's going to go out 10 centimeters. And then another one's 10. And another one. So I'm 30, 40, 50, 60, 70, 80, 90, 100. That's only going to give me 10 boxes. That's not enough. If I look at this one I'm stacking them. 10 centimeters, 20 centimeters, 30, 40, 50. That's only 5 boxes. That's not enough. If I look at this box, I can put 5 along here. So 1, 2, 3, 4, maybe space them out a little bit better. 1, 2, 3, 4, 5. And then I can put 5 along here. So what I'm going to end up with is in this bottom stack, I'm going to end up with 25 boxes just in this. And I can do that 5 times. So I have 25 boxes by 5 layers. That gives me 125 boxes that I can put in there, which is what I need to ship. That's the container that I want to use to ship these little containers. This is an example of volume, the amount of space the box holds, the amount of space that I can put into it. So when we're talking about volume, we kind of interchange two words, volume and capacity. Volume refers to solid objects, the amount of boxes I can fit into that container. Capacity refers to liquid. So capacity would be the amount of water I can put into the coffee pot. That's the difference. That would be capacity. So if we look at these examples to see where these belong. The average cement truck holds about 6 cubic meters of cement mix, or 8 cubic yards. Is that volume or is that capacity? Well, think about cement. When it's in a mixing truck, cement is liquidy. That's going to be, wait a minute. There we go. That's going to be capacity. Contractor has to allow room for a hot water tank. So he's putting a hot water tank in a room and he needs a certain amount of space to put it in. That's an example of volume because the hot water tank is a solid object. The water inside of it, we're not talking about the water inside, we're talking about the physical layout of that tank. An ice cream pail contains 4 gallons. That's the amount that I can put into it. Ice cream before it freezes is kind of liquidy. That's going to be capacity. And a stack of boxes measures 3 feet by 5 feet by 6 feet. That's going to be volume. So calculating the volume of a prism or a cylinder. Let's look at the following objects. You have this on the following page. The area of the base of this prism is 8 by 5. It's 40 square inches. It has a height of 4 inches. Its volume is 160. The triangular prism has a base of 24 square centimeters because it's a rectangle. The volume is 96 cubic centimeters with this height of 8 centimeters. And then I have this cylinder. The area of the base is 50.265 square inches. That's that circular pi r squared. So it'd be pi times 4 squared. And the volume is 251.327 cubic inches. What formula could I use to calculate these volumes? Take a look at these numbers. And the hint that I'm going to give you is take a look at the measurement that we didn't use. When we calculated the base, the area of the base, we used the 5 and the 8. We didn't use the 4. We used the 6 and the 4, but we didn't use the 8. We used the 8 inches. We made it into a radius of 4, but we didn't use the 5. Let me erase that so I'm circling the right one. So now take a look. Press pause after I finish talking. But what I want you to do is take a look at the area of the base and the numbers that I circled and see if you can find a relationship. What did you notice? What I'm hoping that you noticed is if you go 40 times 4, you get 160. 24 times 8, you get 96. 50 times 5, you get this 251. If I go back to that previous page with the boxes that we stacked, think of this as being the area of the base, those 25 boxes. And I did that 5 times. That gives me a volume of 125 boxes. The area of the base times the height of the prism. That becomes, where did my formula go? That becomes my formula, which actually isn't on that page. So let's create a new page. We'll use this page because I'm not going to use it afterwards. The volume of a prism. It is the area of the base times the height of the prism. If I look at this, the base is 8 units. The volume is going to be 8 units. If I stacked another group, which I know I'm not going to do it very nicely, but I do want you to see the different cubes. So if I had put another 8 blocks, the volume is now going to be the area of that base, which was 8 blocks, stacked too high. That's 16 blocks that I have here. Volume is 16. When I look at a cylinder, it is actually the same thing. This one I can actually abbreviate. Volume equals area of the base times h. Get rid of this equal sign in between. Okay? Volume of a cylinder actually follows the same thing. It is the area of the base times the height of the cylinder. However, when we're talking about a cylinder, cylinders are always circles. So this is the area of a circle times the height. That's what you can put into that square that is on that second page. And then we're going to do a couple of examples. What is this volume of this trapezoidal prism? So remember, volume equals the area of the base times the height. When we are dealing with the trapezoid, instead of putting an equals, go area of the trapezoid. So take a moment, press pause, and try to find that one section where we had the area formulas and what the area of a trapezoid is. find is the area of a trapezoid is 1/2 times the height times base 1 plus base 2. Base 1 being this measurement, base 2 being this measurement. So base 1 was 4, base 2 was 10. The height is the height of the trapezoid. That's this measurement right here. So that's 2 times 1/2. Multiply those three measurements together and I get 40 square centimeters. So then the volume of my trapezoid is going to be the area of the base times the height of the prism. The height of the prism, 7 centimeters. This will give me 280 square centimeters. Or sorry, not 280. Yes, 280. Oh, wait a minute. Back here. There's my mistake. Four plus 10. 4 plus 10 is 14, times 2 is 28, times 1/2 gives me 14 square centimeters. Sorry. So then the volume would be the area of the base, which was by 14, times the height, which is 7. When I multiply those two together, I get 98 cubic centimeters. The next example. Which cylinder has the greatest volume? So again, this is at the bottom of that second page. So there's my two dimensions. Which has the greatest volume? A 16 by 3 cylinder or a 9 by 4 cylinder? This is my formula. Volume equals pi r squared h. I would like you to use that formula, press pause, calculate the volumes, and tell me what you come up with. So pi times 3 squared times 16, which would be pi times 9 times 16, gives me 452.389 cubic centimeters. So if I go to this little guy, volume equals pi times r squared times h. What did you get? Because I got the same thing. Their capacities are the same. Just because they're different sizes, they can still have the same capacity. What I would like you to do is I would like you to work on the next 4 questions, or the next 2 pages of questions. Those need to be done so that you can hand them in to me for marks. Thank you.